Now that we've got great films, coated and dried screens, it's time to move on to exposure. Before we go to exposure, we need to register our films. That means that both of these two color films need to be placed in the exact spot or very close to the exact spot on every frame. We're going to use a pre-registration system in order to more accurately and efficiently do this. For placement, core center prints going on the center of the garment are typically placed on the upper 1/3 of the open mesh area. If you're placing your films manually, you set your film upside down on the screen mesh so that if you look through the inside of the screen to the outside, you see your positive image area. For one-color designs, I simply lay down the film on the exposure glass and place the screen on top of it with the image area in the proximate spot and the screen squared up with your film. For multiple color designs, you want to be more exact. While you can align your film to each screen with a measuring tape and a T-square, it is much easier to use a template like you see here. You can find these on screenprinting.com. This template uses a grid so you can place your film onto the correct platen position and then place your screen on top of it. You can do this by using double-sided tape as you see here and then taping the film as you lay the screen on top of it. Or you can tape your film down so it doesn't move. Then place your screen on top of it and put a Sharpie mark in the center of the top and bottom registration marks. Then you can place all your films using those Sharpie marks and tape the film directly to the screen. Make sure to use clear tape that has some body to it so you can easily remove it later. Now that our film is aligned, it's time to expose. There's two things needed for a great screen exposure. First is the proper amount of exposure time for the light to penetrate all the way through the emulsion, and second is positive contact between your glass, your film, and your screen mesh. For this video, we'll be using our Entry 16x20 RXP exposure unit as well as our FX LED exposure unit, both available at screenprinting.com. For more DIY approach exposing screens, check out our DIY print shop videos on YouTube. Keep in mind the amount of time it takes to expose your screen is directly correlated to how much UV light comes from your exposure unit. This 2-bulb entry-level unit has 30 watts of power versus our high-end FX LED exposure unit which has 450 watts of power. This unit is going to be more accurate and faster because of its single source, higher wattage bulb. As we discussed before, positive contact is key in creating a good exposure. An open-top glass unit requires that you create your own positive contact. This is created by using pressure that pushes the film and the screen mesh together. If you don't have pressure, light can easily leak its way around the edges of the image and create blurry or underexposed stencil. On our open face glass units, you want to use the sheet of foam that comes with the unit and put it inside the mesh. Then you put a piece of wood or metal over the film that evenly distributes the weight. Then you put 50 pounds of pressure on top of this. This pushes the screen mesh, the glass, and sandwiches the film in between, creating a great positive contact. More advanced units use either leverage to push the glass and the foam together or a vacuum to suck down the mesh to the glass. Regardless of which unit you have, the key here is positive contact throughout your image area. The next thing that affects the image detail is the direction of the light that exposes the screen. As you can see from this diagram, multi-point exposure units reflect light throughout the exposure area. This is great for overall coverage, but as the light hits the small detail points such as halftones, it can cross-expose them. This is why we used a 5x multiple for mesh and LPI earlier. It gives us some buffer space. Direct light source units, such as our FX exposure unit, uses a much lower multiple because they have directional light and more power, allowing you to expose better screens faster. Exposure times are typically available for your emulsion, mesh, and exposure unit. You can find these on the product page on screenprinting.com. These will give you a starting point. From there are a few tools and signs to dial in your times. The goal of a good exposure is to allow your UV light to penetrate all the way from the front to the back of your mesh. An overexposed screen means that your light penetrates too long and it starts to expose your image area, making it difficult to wash out. An underexposed screen means that your light is not allowed to penetrate long enough. This will leave your emulsion slimy on the back end, allow residue to drip into your image area, and means your screen could break down on press. To calculate proper exposure, we recommend the use of an exposure calculator. This simple exposure calculator, called a step wedge test, measures the density of the exposure by different levels of black filters on the strip. The goal of this step wedge is to expose to the 7 mark. If you are under a 7 mark, this means that you are overexposed. If you are over a 7 mark, this means you are underexposed. As I dial in my times, I use this strip on most every screen. It's a great idea as you're dialing in your exposure times. You create a board, put your exposure times on it. That way, as you're dialing in your exposures and you're adding people to your darkroom operations, you know what your exposure times are, and you can keep track of things as they move forward. Likewise, when exposing halftone detail, it's always a great idea to include halftone gradient scales on the side of the image. This allows you to easily see if you're exposing all the halftones correctly. If you're not capturing all the halftones, you'll need to lower your exposure time or raise your mesh count. For this video, we exposed our 156 mesh overprint screen and our 110 mesh underbase screen on our 16 by 20 inch entry-level unit for 2 minutes using cryocoat. Because of the high mesh gradient print, we exposed our 230 mesh screen in 7 seconds on our FX exposure unit. After the screen's exposed, take it over to the washout sink and get it wet on both sides. This will break down the unexposed area of the emulsion and develop the screen. After waiting a couple of minutes, use a medium to high pressure to blast out the image area, starting at the bottom of the image to the top of the image. Notice that we also spray from the flat or the shirt side of the screen because it is a stronger part of the emulsion. Once your screen is exposed and your image area washed out, your screen needs to dry. If your screen has been properly exposed all the way down to your 7-step wedge, you won't have any residue dripping into your image area. However, if you do, you can still save your screen. Take a little paper towel or newsprint and dab away that residue so it doesn't get stuck in your image area. I prefer to dry screens outside if it's sunny out. However, if it's not, I simply stick them in front of a fan or in a rack. You can also use a drying cabinet to go faster. The plus side about drying the screens in the sun is that while we're drying our screens, we can also post-expose our screen. The post-exposure process makes the screen harder and last longer and is needed for long-run water-based prints using cryocoat. If you don't have access to the sun to post-expose your screens, you can also expose them again on your exposure unit for 3 to 4 times the original length of the exposure. Now that our screens are exposed, dry, and ready to go, let's prep our screens for the printing press. You'll want to look at your screens against light to ensure that you've exposed your detail properly and to ensure there aren't any pinholes in your emulsion. Pinholes can be a result of air pockets in the emulsion, dirt in the emulsion, or spots on your film or glass. You can either use tape, blockout, or even emulsion to block out these pinholes. I like using blockout or emulsion on the outside of the screen. Simply take a cleanup card and dab a little bit of emulsion or blockout onto the screen. Spread it onto the mesh evenly and let it dry. It's good to do this prior to the post-exposure process if you can, so that as you post-expose, you can also expose the emulsion on the screen. Now that we've got our screens exposed and prepped up with blockout, it's time to take them out to the press, tape them up, and set the job up. The final step in the screen making process is to tape up the edges of our screen. This saves from unwanted ink getting onto your shirt and also makes for easy cleanup. To tape up our screen properly, we're using a specific screen printing tape. Standard tapes can either break down when introduced to chemicals or leave a sticky residue on the screen. I have 2 popular tape options here. Our white tape, which is a thin, low-cost tape option, and our green tape, which is thicker and holds up better when printing water-based. I'm also using tadpole tape cutters on both rolls, which is a simple tool and very cost-effective that makes tape cutting easy. Set your screen down on a flat surface and pull out your tape to the desired length of the frame side. The tadpole cuts this tape quickly. Next, place the tape on the mesh first without being transferred to the screen frame. Use your thumbs and fingers to push it all the way to the end of the mesh, tight up against the corner of the screen frame. Then apply it to the frame itself. A good tape job will lay down flat without ripples and should not leave any gaps between the mesh and the frame. Gaps can break and allow ink to go through, so we don't want them. It does take some practice to get the hang of it, but it's second nature once you figure it out. Do each side of the screen frame sequentially so that you can pull the tape off all at once. For a water-based high mesh screen, we're going to use our green tape, which you'll find is easier to put on and sticks better as you see here.